Good morning, viewers. This is Kasturi Day. Today I am back with that last chapter only, that is atomic structure and chemical bonding. So few things are left in this chapter. So first, I will discuss today is the formation of certain molecules of the elements, and then I will start with the ICSE specimen questions of this chapter. So let us, before that, I will request you to please to subscribe my channel and ring the notification bell so that as soon as a new video is uploaded, you will be getting notification. Okay. And if you are a new viewer to my channel, please to subscribe. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And also do meditate before you start your day. Okay, so before starting, we will start with the meditation for just 1 minute, and then we'll start with the discussion, today's discussion. Okay, so for meditation, please concentrate on a point of light. Okay, think to the source of light which is coming on you. Okay, and that light is giving you energy, your whole body is being energized. Your body is being getting enthusiastic. So before I start, I'll just come back to my video. In the last video, I was discussing about the bonds. Okay. That is different types of bond. The ionic bond, then the covalent bonds, and covalent bonds are polar, covalent, ionic bond, there is no sharing of electrons, only there is transfer of electrons. Whereas in polar and non-polar bonds, there is sharing of electrons. In polar bonds, there is unequal sharing of electrons, whereas in non-polar bonds, covalent bond, there is equal sharing of electrons. So these are the main difference of the different types of bonds which we studied. Now, next we are coming to the formation of certain molecules. That is, first is the chlorine molecule. See how chlorine molecule is formed. Here what happens, chlorine has 7 electrons in its valence shell. Outermost shell, it has 7 electrons, and when one atom of chlorine is combining with one atom of chlorine, another atom of chlorine, it is forming a molecule. Okay, so here from the picture you can see that it has this has 7 electrons, this chlorine, and this chlorine is also having a 7 electrons. So it requires 1 electron to form the octet. Okay, so for that it is the two chlorine atoms, they are sharing 1 electron each and forming an octet. Each of them are forming an octet. So as they are sharing 1 electron, so there is a 1 dash between them. Okay, 1 covalent bond between them. So 2 chlorine atoms are joined by a covalent bond, sharing 1 electron of each to acquire stable electronic configuration, that is an octet, of which gas? Of argon gas configuration, resulting in the formation of a molecule. Here, see, there is an equal sharing of electrons, so it's a non-polar covalent bond. Okay, that's why it is a non-polar covalent bond is formed. Next is hydrogen molecule. Now the Lewis structure indicates here also hydrogen has 1 electron extra. Okay, and the valence shell. So it will share To form a molecule, two atoms of hydrogen will share one electron each to form a non-polar covalent bond. Here also, as they're sharing equally, so that means equal share of electrons is formed. So it forms a duplet. Okay, it doesn't have each atom of hydrogen will not doesn't have any will not form an octet, but it will form a duplet because by sharing one electron each. Okay, so to form the duplet, it will share one electron each. That is, there is an equal share of sharing of electrons, and that's why there is formation of non-polar covalent bond. Okay, and that is indicated by a single dash. This is the dash between the two hydrogen atoms. That means one electron is shared. Now we come to carbon tetrachloride molecule. Here, carbon has 4 electrons in its outermost shell. Its valency is what? Its valency is 4. Okay, so it's 4 electrons in its outermost shell, and chlorine has 7 electrons in its outermost shell. So chlorine requires 1 electron, and carbon requires 4 electrons to form an octet, to form a stable electronic configuration. Okay, so what happens? Carbon shares 1 electron each from 4 chlorine atoms. Okay, from 4 chlorine atoms, 1 carbon atom shares 1 electron each, and this one chlorine shares 1 chlorine atom shares 1 carbon atom shares 1 electron from 1 carbon atom. So this means what? See, carbon is at the center. It has 4 electrons extra, that is in the valence shell, and that's why it shares 1 electron from each chlorine atom. So 4 chlorine atoms are required. So as there is 4 chlorine atoms, so carbon will have 4 dashes here. So that is indicated by 4 dash. So it has 4 electrons in its outermost shell, and here carbon shares 4 electrons with 4 chlorine atoms. In turn, each chlorine atom shares 1 electron with 1 carbon atom. This is done by sharing of electrons, forming 4 non-covalent bonds, because it's sharing, each of them are sharing 1 carbon atom each. So that's why what happens, it is a equal sharing is there, and therefore it's a non-polar covalent bond. Carbon achieves the configuration of neon gas configuration, and chlorine achieves an argon gas configuration. Clear? Next, move on to nitrogen molecule. Now, what happens in nitrogen molecule? Nitrogen has how many electrons on its outermost shell? It has 5 electrons on its outermost shell. Okay, it has 5 electrons on its outermost shell. 2 atoms of nitrogen, and nitrogen atom has triple bond. Okay, so what happens? 3 electrons has been shared. Clear? So it it has 5 electrons outermost shell. So 3 electron deficiency of each atom. Each atom of nitrogen is a deficient of 3 electrons to form an octet, forming a stable electronic configuration. To form that, what happens? It requires 3 electrons. So what happens? When 2 nitrogen atoms will combine, it will share, each of them will share 3 electrons, forming a triple bond. Okay? That's why there is 3 dashes. That's indicated by 3 dashes, as 3 electrons have been shared. Okay. So the atomic number of nitrogen is 7, that is 5. First is 2 and then 5. So 2 and 5 is the electronic configuration, and the number of electrons in its outermost shell is 5. It requires 3 more electrons to complete the L shell and attain the electronic configuration of neon. Now, third point is 2 nitrogen atoms come close together and share 3 pairs of electrons with each other, resulting in the formation of triple bond. Thus, 2 nitrogen atoms are bound with a triple bond. Sorry, it's not double bond, it's a triple bond to form the nitrogen molecule. Okay. Next, we come to oxygen molecule. The oxygen molecule, its valency is how much? It's 2. Why? It's a non-metal, but its valency is 2. Why? Because it has how many electrons on its outermost shell? It has 6 electrons on outermost shell. It is deficit of 2 electrons. So what happens when one oxygen atom combines with another oxygen atom? It requires 2 electrons to form the stable electronic configuration. For that, 2 electrons have been shared by each atom. Okay. So when the atomic number is 8, so the electronic configuration is 2 and 6. So 6 means 6 present in the outermost shell or valence shell. So 2 electrons are required to form the octet, okay, to attain the neon electronic configuration, neon gas electronic configuration. Now, while sharing, okay, okay, so that's why it has been, it is, I mean, this as 2 electrons have been shared, so that is indicated by 2 dashes, and that those are called bonds. Okay, 2 double bonds are being indicated by the 2 dashes. Okay, so it forms a covalent bond, that is double one. Then formation of the methane molecule. Now, for forming a methane molecule, here again, carbon has 6 atomic number, that means 4 electrons in its outermost shell, and methane means it combines with hydrogen. Hydrocarbon it is, so it combines with hydrogen. Now, how many hydrogen atoms it requires to form? As carbon has 4 electrons on its outermost shell, it combines with 4 hydrogen atoms like that of fluorine, where it was combined. The molecule was carbon tetrachloride. Here also, carbon has 4 electrons on its outermost shell, and hydrogen has 1 electron on its outermost shell. So what happens? One carbon atom combines with 4 hydrogen atoms to form a methane molecule. Clear? Now, what happens? To get a stable electronic configuration, hydrogen will share its 1 electron and carbon will share its 1 electron. Okay, so each carbon atom will require 4 hydrogen atoms to share its 4 electrons on its outermost shell to form. As there is an equal sharing, it is known as 4 non-polar covalent bonds will be formed. Next is ammonia molecule. Ammonia molecule has 5 electrons on its outermost shell. Okay. So electronic configuration is 2 and 5. Its valency is 3. That means it requires 3 atoms to form a molecule. And ammonia means nitrogen trihydride. That means 3 hydrogen atoms are required to form the ammonia molecule, 1 ammonia molecule. So 3 hydrogen atoms means each hydrogen atom has 1 electron on the outermost shell. So it will give that, it will share that 1 electron with nitrogen. Okay, so it forms, nitrogen forms an octet, and also it will form, hydrogen will also form a duplet by sharing the electrons. So that's why ammonia is formed, and that forms a covalent bond by sharing of electrons. Now next we come to water molecule. Okay. Water molecule has hydrogen and oxygen. Now oxygen has 6 electrons on its outermost shell, and hydrogen has 1 electron on its outermost shell. Clear? Now oxygen, as it has 6, it will require 2 electrons to share to form an octet, and hydrogen, as it has 1, it will share its 1 electron to form the duplet. Okay. Now it forms this water, oxygen forms with hydrogen single covalent bonds. With 2 hydrogen, 2 single covalent bonds are formed. Okay. 2 separate hydrogen atoms are there. Okay. By this, oxygen gets the 2 electrons by completing its outermost shell, and hydrogen atom also receives the single electrons they need for their outer shells. Okay. So each water molecule can form 2 hydrogen bonds. Here, These bonds are known as hydrogen bonds, or you can say polar bonds, because there is unequal sharing of electrons. Okay, now say involving their hydrogen atoms plus two further hydrogen bonds, neutralizing the hydrogen atoms attached to the neighboring water molecules. Okay, then these four hydrogen bonds optimally arrange themselves tetrahedrally around each other molecule as found in ordinary ice. So what happens? Water molecule will combine with another water molecule. One molecule of water will combine with another molecule of water by some bond which is known as hydrogen bond. Okay, and this requires what? It forms a tetrahedral shape as it is found in ordinary ice. Okay, the partial negative charge on the oxygen of one molecule forms the hydrogen bond with the partial positive charge of the hydrogen of other molecules. Okay, so the partial negative charge on oxygen of one molecule will combine with partial positive charge of another hydrogen atom. Okay, so that forms a hydrogen bond. Okay. Next is hydrogen chloride. Okay, now hydrogen chloride is a diatomic molecule consisting of hydrogen atom and a chlorine atom, which is connected by a polar covalent bond because there is an unequal sharing of electrons, right? The chlorine atom is much more electronegative than hydrogen atom because it has more number of electrons, so it's much more negative, electronegative than a hydrogen atom. So there is an unequal sharing of electrons, which makes the bond polar. Okay, and when there is hydrogen and chlorine atoms approach each other at a certain distance between the nuclei, they share the valence electrons, forming a shared pair of electrons, forming the polar bond. A single polar bond is there, and a single covalent bond that is formed. That's why that is indicated by a single dash. Only one pair of electrons is being shared, which is joined by between the hydrogen and chlorine atom by a single covalent bond. Okay. Next, we are coming to some ICSE specimen questions. So these all are about the bonds, and we are now coming to the ICSE specimen questions. Okay. So first question is, write the electronic configuration of the following. 20 Ca means calcium and 40. Okay, so 20 is the atomic number and mass number is 40. Then second one is sulfur. S is denoted for sulfur, and this 32 and 16. Okay, so it should be 16 and 32. 16 is the atomic number and 32 is the mass number. So that means 20 is electronic configuration will be 2, 8, 8, 2, and 16 will be 2, 8, and 6. Okay. Then state the valency of the element having 6 electrons in the valence shell and the electronic configuration of 2 and 3. Okay. So what is the valency of electronic of the element having 6 electrons in its outermost shell? The valency is 2. Why? Because it requires 2 electrons to form the octet. So that's why its valency is 2 and not 6. Okay. Then electronic configuration, if an element has 2 and 3, that means the valence electrons in its outermost shell is 3. Therefore, its valency is 3. Okay. Now draw the orbit structure of each of the following compounds. That is, first is methane, that is hydrogen 1, carbon 6. That is, the valency is hydrogen is 1 and carbon is 6. And magnesium chloride. Magnesium chloride is magnesium is 12 and chlorine has 17. So let us draw the electronic configuration. The orbit structure, not electron configuration, orbit structure. So carbon will be at the center because it has 4 electrons on its outermost shell, so indicated by 2 dots. And hydrogen has 1 electron in its outermost shell. That's why it's indicated by cross. Okay, so let us combine with 1 cross and 1 dot. So there will be 1 covalent bond between each hydrogen atom and the carbon atom, one electron of the carbon atom. Okay, that's indicated by one dash. One electron is shared, therefore it's one dash. So carbon has 4 dashes and each hydrogen has 1 dash. Okay, so that will be forming 4 dashes around the carbon. That forms the methane. Magnesium chloride. Magnesium has 2 electrons on its outermost shell. So electronic configuration of magnesium is 2, 8, and 2. So valence shell will have 2 electrons. So its valency is 2. And this chlorine has 7 electrons on its outermost shell. So its valency is 1 because it requires 1 electron on its outermost shell. So there will be transfer of electrons. Okay, magnesium will give its electron to the chlorine to form the octet, and chlorine will receive the electron from magnesium to form the octet. Each chlorine will receive. So there will be 2 chlorine atoms which receive electrons from magnesium. As magnesium is a metal, it will give up the electrons to chlorine, and chlorine is a non-metal, so it will take the electrons to form negative ion. Okay, so magnesium is giving away electrons, 2 electrons it's giving away, so it's forming 2 positive ions. Magnesium forms 2 positive ions, and each chlorine atom will receive 1 electron from magnesium, so it will form 1 negative ion. Each chlorine will form 1 negative ion. So that will be, the valency will be, therefore it will be written as MgCl2. Okay. Next is give reasons why metals form positive ions. Why metals form positive ions? Because it is very much electropositive. Okay, it will give away the electrons which are bounded on them, that are loosely bound, and therefore they can lose electron very easily, forming a positive charge on it, and that's why they have positive. Okay. Now, in an ionic bond, the bond is formed due to dash of electrons. Why? The bond which is formed is due to transfer of electrons, not sharing of electrons. Okay. Ionic bond is transferring of electrons. And if an element has 2 electrons in its outermost shell, then it is likely to be metallic, okay, and not non-metallic, because 2 electrons, 1, 2, and 3, these are metals. Okay. And 4, 5, 6, and 7, these are non-metals. Electrons they have on the outermost shell 4, 5, 6, or 7, then those are non-metals. Then the atomic number of an element is the number of dash electrons and electrons present in the nucleus of an atom. So number of protons and electrons present in the nucleus. Okay. How many protons it has, that will indicate the atomic number, or if it has how many electrons it has, that will indicate the atomic number. Then the elements which has 4 or 5 or 6 or 7 electrons in its outermost shell, these are non-metals, as I told you earlier. Okay. Then who discovered atoms and write the main postulates of Dalton's atomic theory? Okay. And what do you mean by orbits and nucleus? What are valence electrons? So first question, who discovered atoms and write the main postulates of Dalton's atomic theory? So the first part of this question is, who discovered atom? The Greek philosopher Democritus, who called the Paramanu an atom, okay, which means indivisibles. So he was the first who discovered atom, was Democritus, Greek philosopher. But the first scientific theory was given by, about the structure of matter, was given by John Dalton. So his main postulates are that matter consists of very small indivisible particles called atoms. Atoms can neither be created nor destroyed. Atoms of an element combine in small numbers to form molecules. Atoms are the smallest unit of matter that can take part in the chemical reaction, and the atoms of an element are alike in all respects, but they differ from the atom or atom. These are the main postulates which are given by John Dalton. Another one is there left also, that atoms of one element combine with atoms of another element to form the molecules of a compound. So please memorize this. Please understand and memorize these postulates. Okay. And next part of the question is, what are orbits? So orbits and nucleus. So orbit is an imaginary part where electrons revolve around the nucleus of an atom. So those imaginary parts are known as orbits. And nucleus is the central portion of the atom, central part of the atom, or the nucleus of the atom. Okay, I mean the central part of the atom where there are protons and neutrons present, and those two combined together, protons plus neutrons, are collectively called the nucleons. Okay. Now, the outermost shell of an atom is known as what? It's known as the valence shell. And the electrons are present in the valence shell are known as valence electrons. So the question was, what are valence electrons? So valence electrons are those electrons which are present on the outer shell, outermost shell. And that shell is known as valence shell. So valence electrons present in the electrons present in the valence shell are known as. Okay, now draw the orbit structure of each of the following compounds: sodium chloride, magnesium, oxygen, and argon. So sodium chloride, sodium has 11, chlorine has 17 atomic numbers. So let us see the structure of sodium and chlorine. Sodium chloride, sodium has this one, 281 and 287 Coulomb forces, and this will form a sodium chloride. So see, sodium has now 8 and chlorine has 8, because sodium had 1 electron in its outermost shell, as it has 281. So 1 electron is given to chlorine, and chlorine required 1 electron to form the octet. So it has taken that electron to form this sodium chloride. And after transferring of electrons, it looks like this. That sodium forms the octet here. 2 orbits are there, and chlorine has 3 orbits forming the octet. Okay. Next is, we are coming to magnesium. Okay, magnesium. So magnesium, the electronic configuration is this. That is 2, 8, and 2. Valency is 2. So it has 2 electrons on its outermost shell. Okay. Then oxygen, electronic configuration is 2 and 6. So there's 6 electrons on its outermost shell. Then argon has electronic configuration of 2, 8, and 8, because it is an inert gas. It's a noble gas, so having an stable electronic configuration, its octet is filled. It has complete octet. So outermost shell has 8 electrons. Valency therefore is 0. Now describe the Plum pudding model of atom, and then compare Dalton's atomic theory with modern atomic theory. The first part, Plum pudding model of atom. So after the discovery of electrons and protons by J.J. Thomson, he proposed the Plum pudding model of an atom. After the discovery of electrons and protons, when the electrons and protons was completely discovered, J.J. Thomson proposed what? Proposed the model of an atom, which is known as Plum pudding model. According to this, why it's called plum pudding? Because an atom is considered to be a sphere of uniform positive charge, and electrons are embedded in it. He proposed that an atom is considered to be a sphere, a ball-like structure, having uniformly positive charge, and electrons are embedded in it. Okay. Now, the two positive charge is equal to the total positive charge is equal to the total negative charge, so that an atom as a whole is electrically neutral. The mass of an atom is considered to be uniformly distributed. Okay. Now, this was the Plum pudding model with the diagram you should give. Okay, and then we come to the difference between the Dalton's atomic theory and modern atomic theory. According to Dalton's atomic theory, the atoms are indivisible particles, whereas modern atomic theory states that atoms are divisible into subatomic particles like protons, electrons, and neutrons. Then Dalton's atomic theory also tells that the atoms can neither be created nor be destroyed, but modern theory tells that atoms can be created and destroyed by nuclear fission and fusion. Okay, this was not deduced by Dalton. Okay. Then atoms follow the law of chemical combination to form the compound that is given by Dalton. That is, modern theory says in the formation of organic compound, the law of chemical formation law of chemical combination are not always followed. Okay. According to Dalton, this law of chemical combination is always followed due to the formation of compounds, but in modern theory, this is not always followed according to. The next question is, state the type of covalent bond in the following molecules: ethene, ammonia, and oxygen. So ethene has triple covalent bond, then ammonia has single covalent bond, and oxygen has double covalent bond. Now give reasons for each of the following. Why bonds formed between metals and non-metals are ionic bonds, and why non-metals are negative ions. So first is the metals, they have 1, 2, or 3 electrons in their valence shell. Now they have a tendency to lose electrons. So they combine with non-metals, which has a tendency to gain electrons. So what happens? It gives away electrons. Metals, they give away the electrons, whereas non-metals, they accept the electrons. And that's why there is transfer of electrons. Okay? That's why they form ionic bonds. Then our second question is, why non-metals have negative ions? Because non-metals have an electronic configuration of 5, 6, or 7 electrons in their outermost shell. So therefore, they have a tendency to gain electrons to form the negative ions. That's why they are negative. Okay. Now, give 3 conditions for the formation of the covalent bond. First condition is combining atom should be short by 1, 2, or 3 electrons in the valence shell. For forming a covalent bond, 3 conditions are required. So what are the first condition? What is the first condition? First condition is the valence shell, the combining atom which wants to combine, that should have 1, 2, or 3 electrons short in their valence shell. That means it should require 1, 2, or 3 electrons in there to perform the octet in the valence shell. Now, this electronegativity difference should be very small or 0 between the 2 atoms. Electronegativity should be 0. And the 2 atoms should approach one another accompanied by decrease of energy. Okay, they should combine with one another by decrease of energy. So this is all about this chapter. We will discuss next with the back questions, okay, and some other extra questions. If I find, then I will include them for your benefit, so that you can get better knowledge of this chapter and also can score good marks. Okay, so let us stop here. And before that, I will request you to please like, share, comment, and do subscribe if you have not subscribed yet, and also ring the notification bell to get the notification as soon as a new video is uploaded. And one more thing, that please don't forget to meditate before you start your day. Okay, so thank you for watching and have a good day.